Alright, my name is Clark Vowels, and today I'm going to be presenting on Gottfried Wilhelm Leibniz. Now, Gottfried was born in Leipzig in 1646, and he was a prodigious young man. And he actually had extensive access to his father's library at the early age of 7. And this was huge for his academic career because he was exposed to a lot of texts way earlier than most people through reading his father's extensive library. Because of that, he actually became proficient in Latin at the age of 12, which is pretty early at the time. And he was able to really gain a love for learning and acquiring knowledge, and that really contributed to his discoveries later on in life. Now, because of his studies, he enrolled in the University of Leipzig at the age of 14, which is, again, it seems early now. It was also early back then. And he later would study law at the University of Altdorf later on in his life. Now, if we want to look at some of his early works, he actually wrote his first book when he was 20, which is kind of crazy considering many of the people in this class are barely that age. And his first book was called The Combinatorial Art. And this was a book that was way ahead of his time. It actually details different ways of expressing things in real life through numbers and symbols and types. That's kind of an early foundation for modern computing. So this is something that has been referenced in some of the early ways that we have created computers to interpret the real world in the 21st century. And so pretty incredible that he was doing that back in the 1600s. And the rest of his academic career was very, very diverse. He worked in almost every area of natural philosophy or natural science. And he, so for example, he created a mechanical calculator called the stepped reckoner. And this was the first of its kind. It was able to do addition, subtraction, multiplication, and division of different numbers between 0 and 9. He also invented an early form of binary notation, which kind of derived from his early work in combinatorial art. And binary notation is a way of representing the world in ones and zeros that a computer can understand. So it's basically, if you're able to turn on and off circuits, how can we turn that into something that's functional for a computer? Additionally, he revolutionized European libraries by introducing a new cataloging system that was adopted by libraries all across of Europe. And he also developed a philosophical system that really tied into some Enlightenment ideals, and that was called monadology. And so monadology kind of centered around the hypothetical idea of monads. And so it was based on the idea of hypothetical monads being the smallest possible substances. So if you imagine you take a particle and you cut it until you get the smallest possible thing. And in order for something to not be divisible, he figured, it wouldn't have any shape, it wouldn't have any volume, it wouldn't have any size, you couldn't see it or look at it, but they must exist because something must make up the fundamental particles that cannot be split in half. And so he had figured that if all monads were the same, they must have to work in perfect harmony in order for the world to exist. And he believed that it was a pre-established order that created this perfect harmony, which also tied into his proof that he had created for existence of God. So he'd actually created a mathematical and philosophical proof for the existence of God through logic. And so his logic was that God is perfect, and since existence is perfection, therefore God must exist. So if all monads work in perfect harmony and they maintain a pre-established order, then God must have created that pre-established order. And so this kind of all starts to tie into the Enlightenment era that Leibniz was part of. And he had two main philosophies that I could identify that really tied into the Enlightenment. And the first one was rationalism. Now, Leibniz is considered a prime example of rationalism. Rationalism essentially is the idea that reason is the chief source of knowledge. So instead of God or divine beings being the chief source of knowledge, or the Bible being the chief source of knowledge, he believed that ingenuity and human reasoning was the way we create knowledge. And this is a real like core Enlightenment ideal. And it's kind of where the scientific method came from, figuring out how to test a human idea to figure out if they have a fact or if it's not true. And so this enabled Leibniz to think outside the box, and that really led to a lot of his groundbreaking discoveries by being able to free himself from a lot of the previous presumptions that his predecessors had kind of taken for granted. And the second idea that kind of tied into the Enlightenment era was Leibniz being an idealist. And so essentially an idealist believes that reality is entirely a human construct. So because of this, he believes the greatest form of reality are actually the ideas that humans can come up with. And so this ties into his theory on monads, because monads are not something that humans can actually observe, but can only be really exist in the minds of humans, or they can only be observed through thought. And so in his mind, because we can think about them and because we can envision their effects on the world, they must actually be real, even though it's impossible to actually observe them. And this idealism is kind of a prime example of the type of thinking that the Enlightenment really enabled for people to think outside the box and come up with these crazy ideas like Leibniz had. And even though nowadays his idea of monads seems kind of silly, it was an example of the type of thinking that was necessary in order to create actual change and enable some of the more prominent scientific movements that influence our society today. Perhaps his biggest contributions were in the area of calculus, and this is pretty much what he's known for. So in 1675, Leibniz successfully used integral calculus to find the area of a curve under a graph. And so this is a form of calculus that essentially takes a graph, maybe it's some crazy curve, and based on the equation or the formula for that curve, is able to find the amount of area underneath it. And that's a pretty advanced technique that we use computers for now, but he was able to do it on paper, and he established a modern notation for calculus that we still use today. So for example, on the right, that symbol that looks like an S is called a summa. And he was the first person to use it, and because of that, we still use that notation today. And on the left, he used d over dx, or derivative notation, or differential notation, and that is the way we describe a differential function, or the opposite of an integral. And so all in all, he basically developed the foundation for all modern mathematics, calculus and beyond, which really has enabled us to advance as a society into a high technological age. Now, Leibniz and Newton have a complicated history, because Leibniz is actually credited alongside Newton in the creation of modern calculus in the 1670s. And Leibniz didn't formally publish his work until 1864, even though he had actually used calculus properly all the way back in the 1670s. And because of this, he was accused of stealing Newton's work. There are rumors that he had maybe looked at one of Newton's early documents, and because he had discovered it first but not published it until later, he was accused of stealing Newton's work. And the British court actually sided with Newton, and Newton was given the title of knight, partially for his work with calculus. But now we know that likely they both developed their own versions of calculus independently, and there wasn't probably any stealing. But it's just kind of goes to show how the Enlightenment era really was a catalyst for a lot of scientific and philosophical development at the time. Now, the legacy of Leibniz is interesting. He actually went to the grave dishonored by the accusations of stealing information from, or stealing discoveries from, Isaac Newton. And because of this, there are reports that his grave was actually left unmarked for 50 years after his death. But today's discoveries are widely acknowledged as being the basis for many, many different fields of science. Libraries, calculus, computation, and a lot of philosophy was really ahead of the times, actually. And his binary notation, I think, is kind of just one of the most incredible things for him to come up with. There weren't even really computers back then, but he was thinking about a way to talk to something that didn't exist. Overall, Leibniz was an incredible man for his time. He had a lot of great discoveries, even though they weren't all credited at the time. And he was a prime example of what it means to be an Enlightenment thinker in the late 1600s. These are my citations. I used a Wikipedia article, these are my citations. I used a Wikipedia article, 2 Britannica articles, a magazine article about modenology, and a crash course video about Newton and Leibniz's rivalry in calculus.